Before I do that, I have a question for you. What do you mean by engineering? I think all of you, I'm sure 8 and 9, 10 people there, they might be thinking, should I take science? Should I take something else? And 11th, 12th, I think you are more kind of, I hope maybe kind of studying science, maths, or some subjects. So what does engineering mean to you? Anybody?
Yeah, Vinayak, you can answer.
Engineering is the process of designing or making something.
Pretty good, Vinayak. So it's about creating something, right? And I think we'll come to that definition. I think it's very important to keep that definition in mind. And I will tell you why it is important on the next slides. But on the introduction, you can see a few pictures there. So I don't know how many girls we have in the audience. One message I have is, and I have now 20 years experience in engineering. What I have seen is many girls are actually very good engineers, but they don't realize it when they are in school. So this is something which I would like to encourage all girl students on the call to think about your passion. You never know. I think you have a very successful engineer within you. So never think that engineering is only boys thing. Most successful engineers, at least I have seen, are actually girls. Okay. Other thing you see here on the slide is a picture with a boy or man, and it's very glamorous. I'm sure. I think a lot of people can get. It's like a movie scene. A plane and a person. It's very glamorous, but there's a lot of hard work behind it, and that's what you see in the other two pictures. So as Vinayak just told, I think engineering is to create something. Creating is not easy. I think that's a lot of hard work. So as you are exploring your own career, I think you need to question about why you want to do engineering, what engineering means to you. There will be path of hard work, which I just wanted to highlight. Before we go too far, I just want to quickly introduce myself. I think, as you know, I'm Jitendra, and I'm just here to help you discuss about aeronautical engineering. My own education has been, I started with a diploma in mechanical engineering, and then I went on to do a degree in aeronautical engineering in one of the specific branches called propulsion. And then I went on to do masters, M.Tech in aerospace engineering, specifically in aerodynamics in IIT Bombay. So that has been my educational journey. As you would see on that, I didn't start it as an aeronautical engineer, and as I will tell you, I didn't ended up also being aeronautical engineer. So that gives you a flavor that it's a journey. It may not itself be a destination. From a working point of view, I started my career with Indian Space Research. So I was very much motivated to go into aeronautical, do space research. I spent 3 years there. And after that, I actually moved out and went to General Electric and actually left aeronautical and doing energy system. And as I would tell you in the next slides, when you think about your aeronautical engineering career, if that's what interests you, you would also find that that is not the end of the road. Essentially, what you learn there can be applied in many different ways. So this is what I did in 2004, where I went into designing engineering energy systems. That's what I did for 6 years. And after that, I went on into a wind energy. I think the windmills and the wind energy, you might be seeing the big machines sometimes, if you go on the highways. So this is what I do right now. And interestingly, it's not very far from aeronautical engineering. Once you know how to design a wing of an aeroplane, what I'm doing right now is I'm just designing the wing, which is rotating and creating energy. And recently now I'm based in China, and I've moved more into management roles of it. So that's quickly about me. This is one thing which is important to highlight. I think science, I'm sure, should amuse you and fascinate you if you are into, let's say, if you're interested in that. I think I'm sure you are, because that's why you are in the call. And I think even for the common man, I think science can really fascinate us. What is possible in the world. But it is engineering that actually changes the world. And this is said by Professor Isaac Asimov. And essentially going back to what Keshwan told about, it's about creating something. So what engineering does is it uses the scientific principles, to build something useful and valuable. Right? So it's not about building anything. It's about building something useful for the humankind, or the world, and it should be valuable. At the same time, it should use scientific principles. So essentially, engineering career is all about understanding science, but perfecting the principles and building something out of it. Any questions till now? Before we jump a little more.
No, sir. No, sir.
So I think the question which probably you may have at your stage in the school is, how do I become a successful engineer? And this is, I just wish that I had tried engineers when I was in school, because this I was not able to answer unless after 10 years in my career, right? So I thought maybe to give you this summary, because this is something which at least I want all of you to take with you from this session. I'm sure you're in this call, everybody wants to be successful, and the success can mean different things to different people. Maybe so for somebody you think success may be money, for something maybe success may be some traveling, success may be some good job, success may be home, whatever. But essentially, when you're making engineering career, whatever definition of your success, how do you really strive it? And to me, time and again, I have seen last 20 years, there are 4 factors, and there are only 4 factors I could think about which really contribute to it. And the first and foremost is the interest. Am I really interested? I think I've seen many times where maybe students take engineering just under the pressure that my friend is doing, or my parents want me to do it, right? So this is some first question you need to really ask. Am I really interested? Because as we just told, engineering is all about creating something useful. So are you interested to create something useful? Are you interested to learn scientific principles and apply them? So that is the first thing you need to know, to have, to make it successful. Second is the knowledge. And I think I'll tell the third one, which is on the skill, knowledge and the skill. What is the difference? Knowledge is all about, do I know? Skill is all about, can I do? So any examples you can think about what is knowledge and what is skill? Can you give me some example about in your own schools now? What is knowledge and what is skill?
Vinayak, you want to speak?
Yeah, so in school, the math question is like, you need to know, for knowledge, you need to know, do I know this scientific, this mathematical operation? And the can I do part is like, can I do this? Do I know about this?
Yeah, kind of. So let's say you're a pilot of an aircraft. Right? So what is your knowledge and what is your skill? Maybe you know the aircraft. Maybe you know how it works. Maybe you know how many types of aircraft. Maybe you know what should I do if my engine is, heating up too much, whatever, But the skill is, can I really fly it? Can I sit on the chair and fly it? That's a skill for a pilot, right? Do I have a skill when the turbulence come to manage my aircraft? That's a skill. It can be applied in anything. I think it's. I think many of you, I presume, would be doing some kind of software, some coding, or some just understanding. So that's a skill part, right? If can I make a hello world program? That's a skill. Can I know how the C language works in a computer? That's a knowledge. So just to, and this is both important as you go in your engineering career, you need to know more and more. At the same time, you should be able to do more and more, right? So it's possible that I know how is the design of aircraft. I can read on Google, I can read, okay, I know exactly how aircraft is designed, but can I calculate? Can I use my physics, the mathematics? Can I really calculate and tell my number and tell that this is how to do it? So that's a difference between knowledge and skill. The fourth dimension in this is the market and application. So is there a market for what I do, what I know and do? So essentially what you're telling is, whatever I do, is it found to be useful and valuable by somebody, right? So that's what I think this session is all about, to talk about what is the market for aeronautical engineering. So that's why this session may be seen from that point of view. At the same time, I will talk about what is the knowledge you may acquire if you go in that direction. But I think that we will leave apart the skills and interest part. I think interest is for you to explore, and I have my own suggestions about it. But the skill is as you go on, you kind of develop it, right? So this is the 4 factors, and I think if you are really smart to develop and balance these 4 factors, time over time, I can guarantee you that you will have a successful engineering career. I think you will have a successful career regardless of whether it's engineering or non-engineering. I think these 4 factors are really common. Now tell me, out of these 4 factors, which is in your control and which is not in your control? Anybody?
Sir, market and application is not in our control.
Not in your control. Good. So what should
And
you do?
knowledge and skills and interest, these are in my control.
Knowledge, interest, and skill is in your control. Great. So if it is not in your control, what do? You try to find out, and you kind of need to keep knowing. And that's why I think this session with try engineers, trio teachers help you to do that. So that's one thing. But coming to, you told knowledge, interest, and skill is in your hands. Is it really? Would your interest change with time? Would your skill change with time? How do you plan to do that?
Sir, my interest change with time. But I think knowledge is in my control.
So maybe I agree. So one thing which you may realize is, and I think at least I've seen many cases, people doing engineering and then and you kind of you have this movie 3 Idiots. I think I'm sure most of you would have seen this. You're trying to do your heart is somewhere else and you're doing something else, right? So this is a typical challenge after 12th when you do engineering, because at that moment of time, maybe you think you have interest, but then you're not sure what comes on your way. So this is why it's important to just look little beyond and then try to calibrate your interest. and then you are able to take better decisions. Okay, let's talk about aeronautical now. I think we talked about engineering. One term which you will always find sometimes confusing is people will tell, should I do aeronautical or should I do aerospace? What is the difference? I think essentially it's a very vast area of study. Aeronautical in itself, the word means it deals with the navigation through air. So what basically you are going through air, that's aeronautical engineering. And aerospace is basically navigation through space. From the education point of view, I don't find it is very different. It's not very different from a degree point of view. They're just different application. So maybe you have application of making an aircraft, or maybe you have application of making a launch vehicle going to the space, or maybe you have application of making a satellite, which is going to be in the space throughout. So they're just different applications. Don't worry too much. If somebody tells you that should you do aeronautical or should you do aerospace, more important is, as I just told you before slide, do you have interest? Are you doing it the right place? Do you understand a little bit on the market and knowledge you need to acquire? I think that's something which is more important than thinking about aerospace or aeronautical. Now, aircraft or any of these pictures I just put here, they are just huge systems. They're just application to create something. They cannot be done alone. Essentially, they are just a combination of different engineering. What is mechanical engineering? You basically create some machine, a mechanical part, engine, or a nozzle in the case of this rocket. They are mechanical system. You need to have a mechanics to be able to operate things. Right? So you kind of need to know mechanical. These systems cannot operate without electrical. I think if you just Google, I think you will find there is kilometers of wire inside one aircraft. In one Boeing 747, there would be at least 10 kilometers of wire. You need to know electrical to be able to operate such system, to be able to design such system. All the systems also will have a heavy electronics. So you have an application of electronics into it. It could be communication, it could be navigation of this. They cannot work without instruments. So you need to have application of instrumentation engineering. All the systems has to be manufactured. So you need to have materials to do it. It can be aluminum, titanium, could be composites, and then you suddenly get into engineering of how do I design this material? How do I manufacture this material? That's material science. And the production, Finally, as engineering, it's all about producing it. So even if I can design it, I need to put the machine, and start doing it. That's a production engineering. So overall, I would say aerospace or nautical, they are just the combination of different basic engineering principles, basic engineering disciplines. And aerospace and aeronautical is just an application. It's the same like telling automotive, automotive also may need all this, or energy engineering, it will also need all this. So they are more of application. From the education point of view, I think you may have a dilemma. Okay, should I do a mechanical engineering or should I do aerospace engineering? Choice is yours. I think there are advantage and disadvantage in both. But even if you become aerospace or aeronautical engineer, it is not realistic that you will be knowing all these disciplines. That's not the intention of making an aeronautical engineer. Maybe you know a bit of everything, but you will still choose something which you will go deeper. For example, for me, I started my career as mechanical engineer. I became aeronautical engineer, but then my base is still mechanical. And recently I'm getting into material science. I don't know electrical electronics, but I know in my system, I will have some other engineer who will know it. Right? That's how the teams are built. That's how the systems are built. So this is just to give you a quick snapshot on, what is aerospace. Maybe any questions? I will just let's make it interactive here. Maybe you have some curiosity question. What is that? What is this?
Sir, so can it happen that an aerospace engineer, after getting a degree of this aerospace engineer, then specializes in mechanical engineering, or a mechanical engineer, after getting a degree of this mechanical engineer, specializes in aerospace engineering?
I think that's a very good question. So essentially, it will mostly happen as a basic discipline, like a mechanical engineer coming and becoming expert in aeronautical engineering. Because this is the application. So this is basically, let's say, Indian Space Research Organization, the picture where I put. That is like your end job, but to do that, maybe before that, mechanical, and then you're trying to learn aeronautical, or you decide that I will just do aeronautical, and I will learn this depending on my subjects. But it is very less likely that, that's also actually likely that if you become aerospace engineer, and then you decide what do I want to do, you can very well take a mechanical job. It's possible, and then you try to apply what you learned in aerospace into some other system. For example, what I did was energy system, because the engine in aircraft and the engine used to produce the power, electricity, is similar. So I just learned aerospace engineering. I did some years, and then I went, okay, now I like to do more power application. So then I can change it. So from education point of view, I would recommend to start basic discipline and then go into aeronautical. Or if you are very, very interested and you are very, very sure this is what you want to do, then you can right from start go to aeronautical. And in that, you'll get subjects to build some of this. I hope it answered your question.
Thank you, sir.
Any other? So what do you learn in this engineering core subjects? As I told, I think it's a complex system. I just put 4 pictures to show you some different things here. And this is just an example of aircraft. It can very well be a rocket. It can very well be some other engine part, but I think it's easier to understand the aircraft. So I just put an aircraft here. I think the first picture tells that you need to kind of have one understanding about how the air flows over the aircraft, because aircraft is all about flowing in the air. So you need to know airflow, or fluid dynamics, as it is called, aerodynamics it is called. So that's one part of the subject you kind of learn. Second, if you see on the right side, I think essentially it is just an assembly of different mechanical parts or a structure. So you basically will have subjects which will be related to what is called as aircraft structures. To do structures, you need to know materials. So you'll have subjects like materials. Now, the aircraft is not going to fly by itself. You need an engine. And that itself is a big branch of the study. So let's say you choose to become an aeronautical engineer. You will also, after some time, be forced to decide what do you really want to become. Maybe you will find that you cannot become everything. Maybe you want to become an engine person, propulsion person, or do you want to become aerodynamic person, or structure person, or electrical avionics person. So this is also which, as a matter of specialization, even in the degree, the later years in the degree, this is what happens. And if you go to the masters, level and PhD level, this is what then you need to decide. So you'll have subjects of what is called as propulsion. Now, with all this, aircraft is not going to fly by itself. You have a lot of electrical electronics behind it. You have control systems. You have guidance, avionics. Avionics is nothing but aeronautical electronics. So think about this. Maybe some of you are more inclined and interested doing electronics, and maybe you question, do I have a future in aeronautical engineering? Yes, of course. Maybe you decide, maybe you can start being an electronics engineer, do your degree, and then you do your master's in what is called as avionics, and essentially in master's, then you start learning about how do I apply this electronics into the function of an aircraft. Some of you may be doing interested in software engineering. A lot of this has to work with software, right? Many things are automatic in this. So there's a lot of software engineering coming into it. And I don't know how many of you have heard about the Boeing aircraft 747 MAX being grounded for many years now. One of the mistakes they had was actually in the software. So that's why it is very important also. So that this gives you an overview of different subjects which you might face in your engineering if you choose to do that. Going forward, I think career opportunities really lie at different stages. As you would see, engineering is all about creating something. Right? How do you create something? Basically, 4 steps, right? You need to design and research. You need to manufacture it. You need to operate it, and there is some mission. For example, if I need to launch a satellite, maybe I'm not the design person, but I'm going to ensure that mission goes in the orbit of the satellite. That's another stage. Or I need to maintain. So these aircrafts have to be maintained every few hours after flying, right? So your career can come from any 4 directions. And many times people start in design and they end up in manufacture, or they start directly some degree to start learning maintenance, if that's what interests you, and there are a lot of opportunities actually in the maintenance.
Sorry to interrupt.
Okay.
जोर से बोलोगे, मुझे सुना ही नहीं दे रहा है काफी.
Sure. Thanks for highlighting it. I hope it is better now. So I think these are the 4 stages you will find where you might have a career opportunities. So as I told, you have to have interest, knowledge, skill, and market. So maybe as you may not be in this session, but as you think about in this direction, you need to also start thinking about what knowledge I need to gain if I go in any of these 4 areas. What is the market in these 4 areas? Do I have an interest in design or manufacturing or really operating something? So this is the kind of questions you may have to ask yourself. Let's see. Okay, any questions here? I think this just talks about what will you learn. I think maybe this is a very I didn't put a lot of things on the slide, but I wanted to maybe take your questions here about what is your curiosity to know what this engineering is about, like what subjects you will learn, you may learn.
Yeah, so Vinayak and Hitans, you can ask your doubts and your questions from sir. Because, sir, these 2 people were waiting for you.
Sir, so this is not related to career, but I just wanted to ask, you told that the software engineering is required for flight and all. So any hacker, like a professional hacker, if he could hack the flight, so can he control or hijack the flight?
Oh, I think that's the question beyond my technical capability. But the way I would put it is, the moment you put any hardware and software into a system, and as long as it is connected to internet, Wi-Fi, or even the communication systems, theoretically it is possible, to do it. And I'm sure when it is possible, there are also possible to have a countermeasures to avoid it. So I'm sure the people who may be specializing in this lately do consider the cyber attack part of it. In the space mission, definitely, this is very, very critical. I can tell you the example of, let's say, Indian space missions. Not many people, even in the ISRO, will actually know the code, the password in terms of accessing the satellite. So there are multiple layers of security to avoid that possibility, as you just told about hacking. Because theoretically, it's possible that you actually can hack a satellite and make it go out of orbit, for example, and that's like crores of rupee going into space. So yeah, possible. And then there are a lot of countermeasures taken to do it, to keep it safe. Yeah, one more boy asking the question.
Hello, sir.
Yeah.
Sir, I want to actually know that what actually happened on the Boeing 747 aircraft. I'm very eager to know that.
I think that's a pretty big subject, and I think if you are really interested, I will pass on the good links to Suraj to share. But in nutshell, I think it so happened that as the aircraft was developing into the new versions, which is called Max, they had the limitation about the engine size and how they can accommodate. But that made their aircraft more unstable. But they didn't have much choice. They thought they will manage this instability of aircraft with better controls in the software. So the software became very critical. Otherwise, software do have a very important role, but at the same time, aircrafts are designed to be stable themselves. Even if everything fails, aircraft is just going to glide and come down. That's how they are designed. But in this case, they were not very stable by itself. And then it went on to the software, and then it so happened that the software and the system also had some bugs. I think it was a combination of many decisions which led to this happening, and that's why it is difficult to reverse everything, which basically means you need to design totally new aircraft. So I would say the decision of designing in this direction without creating a totally new structure or the shape finally affected the failure. But I think the story is much deeper and much interesting. So I think if you are interested, I will pass on some links to both.
Thank you, sir.
Let's move forward. I think so. Maybe you have question about, okay, even if I do aeronautical aerospace engineering, what will I do? Where will I go? What is my job? And here I just put a list of different engineering companies you may end up, being. So it's like a space research centers like NASA or ISRO. In India, we have a lot of aeronautical development establishments. Even outside India, you'll find many. Aircraft manufacturing companies, they would need aeronautical engineers. I think in India, we don't have much at the moment, but internationally, yes. In the airlines and aviation industry, there is always a demand for aeronautical engineering because these aircrafts have to be maintained. So they will have engineers department to be able to maintain the aircrafts. If you're more research oriented, a lot of defense research and development organization in India do recruit aeronautical engineers. So same thing, aircraft, same thing like a launch vehicle, you can very well get the same system as a missile, right? Missile is also a aerospace system. You know? So that's what the DRDO and defense research do. Defense technical services, I think that's very interesting. Maybe some of you have aspiration to be in defense, maybe Army, Navy, or Air Force. And if you also have a heart of an engineer, they also recruit engineering services because all the ship and aircraft, they have to be also maintained. Flying clubs, I think that's option. Then we have Helicopter Corporation of India, Hindustan Aeronautics Limited. That's a very big organization which recruits aeronautical engineers every year, and they do manufacture fighters and different aircraft. And recently, they're starting manufacturing Rafale aircraft in India. We talked about private airlines. Then we have National Aeronautical Laboratory, and that's more on the, if you are interested on the research side, then this is in Bangalore. They also have a lot of aeronautical engineers. Furthermore, private sector, you will get many companies, multinational companies, who actually do design in India now, including the engines, the aircrafts. Boeing has a center in India. Airbus has a center in India. GE has, Siemens has, everybody. So they also design in India, and that can be one of the opportunities. Similarly, in private sector, there are a lot of aircraft parts manufacturing companies coming up. Quest is one of them, and essentially they manufacture the aircraft parts and they supply it to the aircraft company. So they also would need. So this is all the kind of different dimensions where you may be able to go. But apart from that, once you learn aeronautical engineering, you're not only limited to aircrafts and spacecrafts. You can basically also go in some neighboring areas like I do, like power turbines, wind turbines, drones, autonomous vehicles. And I mean autonomous cars. What you might have heard about Google, they do autonomous car. But aircraft fighters, they already have this fly-by-wire autonomous system. So there is a lot of research there which is coming, and that is now being applied to autonomous cars. So you basically even can go and think about in that directions over time. So the point is, it does not limit you, but you need to know your market, where you can contribute.
Yeah, hello, sir.
Yes, please.
Yeah, so Suraj, I would like to ask you a question, sir.
Sure.
So, sir, you have spent some time in ISRO, Indian Space Research Organization, right? And when we listen the name of ISRO, then something fascinating comes in our mind, especially students, right? From a student's perspective. So, would you like to share any of your experience or anything which you think students can easily understand from ISRO?
And you mean some example of a mission, or?
Yeah, correct. Anything which can be explained to the students, or they can understand something fascinating happened with you in any mission or something.
Yeah, so I think that's a very good point. Let me go back here to this picture. And I think I have a quick story in that case, and you may also very well Google. It's a very famous. So India has a different kind of launch vehicles. They're called PSLV, GSLV. GSLV Mark III. What you see here on the picture is GSLV. It's the geosynchronous launch vehicle in the orbit. And this is the advanced version of that. Before this, there was a GSLV Mark I. And when I joined ISRO, just before I joined, if I'm recalling, I joined on 18th of April, and 12th of April 2001, there was a GSLV, first GSLV, which was supposed to be launched, and it is launched from Sriharikota. That's the picture you see here.
Right.
It so happened that a week before I joined, there was a major accident, and this was the first flight of GSLV for India. It was called D1 mission. You can search GSLV D1 failure. So it's kind of interesting. You're going, you have a lot of passion, you want to go and join ISRO, that's your dream, and just before 1 week, you see on your TV that there is accident of this launch vehicle. And then you start wondering, okay, what will I face going inside? So when I joined, the very first lab I was assigned to, I could see engineers working very hard to solve this accident, because the challenge was to launch the vehicle again in very short time. And I think it was actually launched end of April 2001. And it was only a matter of 15-20 days, if I remember. But that was the first learning I had, where how passionately the engineers were trying to understand. And it was actually a case of a fire. If you see the nozzle here, the very moment the aircraft, the launch vehicle ignited, there was a fire on one of the strap boosters. And the only good thing was it was not launched, so it was still on the launch pad. So that became very mesmerizing for me. And finally, our seniors, when they were solving this, we could discuss with them what is the problem, And the problem was actually how the gas flows and air flows, and there is a design, and the gap is different. Because of that, the fire goes up, and then you don't have taken care of some of the heat shield and blah blah blah, things like this. So finally, it was just a combination of material, heat, flow, and that's what this lab was studying, and I was fascinated, and that's actually what I did for next 3 years, was to just keep studying this area of which is called rocket plume, and this became my specialty later, to understand the rocket plume, as it is called, and why it is important in the launch time and later. So that was very interesting, just before I joined ISRO, and just next few weeks, when the next mission was launched successfully, I could see the cheer in the room. I could see the people cheering on the video, that they really found the problem, and it was successful the next time. It became a very big mission that time. So that was a very interesting anecdote, from that times.
That's seriously a very good story, sir. Sir, I would like to ask another question, and that is from last 1.5 years or 2 years, everyone are talking about Atmanirbhar Bharat, like whatever we will create in India, right? So why don't we have our own Google map? Because we are listening, I think ISRO is working on Gaganyaan mission, and that is something related to our on Google map, Indian Google map. So
Right.
what are the reasons why it's taking so much time?
Okay, lately I'm not part of ISRO, so I can't comment what are the reasons. But as you rightly told, I think it's all about putting many satellites for that purpose in the orbit, right?
Right.
And it's a matter of what you do with that. So I would assume there is no technical hiccup to do it. I think it is a matter of time, money, and priority.
Correct.
And essentially, India is highly not something new for India now. Right? India do launch satellites for many other nations. Right? So it's a good use, but I'm not sure if that takes the capability of India to the next step. I think, for example, we had the unsuccessful landing of a rover on
Moon,
right?
Yeah.
Now that's a frontier. That's you're talking about a frontier problem of research. So I'm sure and there are a lot of reusable and re-entry vehicles and things like that. So I would assume ISRO putting a lot of hard work into getting into new frontiers, and putting more satellites is more of a commercial decision about when you want to do it, who is going to buy this, even if you do it, if you want to put all this money. So I would say it may be more because of that reasons. I don't think it's a technological problem.
So students, if you have any question, anything which is troubling you, you can ask. Anything related to aeronautical or aerospace, you can ask to sir.
Sir, when the rocket is launched, and after the first level separation, the thrusters are just fallen down. So where did the debris of the rocket go?
Oh, that's a very interesting question. I think you guys are very advanced. Huh? So now this debris is totally different challenge. I don't know, recently, last month, if you would have seen the news, one of the Chinese rockets was falling on the Earth, and everybody was worried about where it will fall.
Yeah.
So space debris is an issue, and that's an international issue about during the rocket launch, you will have the first stage, second stage, third stage, and sometimes fourth stage. All these stages are going to separate at their own height, and they are going to fall back. And depending on what is your altitude, and based on the gravity, you might take many days or months to come back, or you might just come, if you're in atmosphere, just going to drop in. So, for example, the way mission is planned, if you know, the Sriharikota is actually lying on the sea. So mostly this debris, initial stage debris, would go in Bay of Bengal for India. And typically what happens is there is a tracking going on. Actually, ISRO has some tracking centers on the islands in Andaman and Nicobar, and also in Mauritius and some other islands, where they do track the stages where they are falling. And typically there is also a lot of calculation happening about they should not fall on any habitated place. But the chances are very, very remote. So this is how they're designing the trajectory to make it fall. The bigger problem is when the satellite, and the higher stages in the space, they are going to go in orbit for many times, many days, and then it become a little unpredictable of how they will enter the Earth and where they will fall. So that's an open challenge at the moment for research, and there are many work happening in ISRO for that.
वो सर ऐसा नहीं है ना, मतलब हम कोई भी डेब्रीज ओपन स्पेस में छोड़ रहे हैं, लाइक दैट?
नहीं, ओपन स्पेस में डेब्री छोड़ रहे हैं, और वो हर कंट्री छोड़ रहा है, और उसके लिए ट्रैकिंग है, हर डेब्री का एक नंबर होता है. So if you get the website, I think I can also pass on to you. You can actually search. There is an international agency which track the debris, and they will know कि debris India से आया और वो कहाँ है अभी.
It's kind like something we are polluting the universe.
Yes, I think you're right. You're right. So it is like a polluting the universe, polluting the space, I would say, not the universe. But that's one outcome. The bigger problem than the pollution is because they are going to have their own life. After that, they're going to fall back, right? Yes, or they're going to just go into space. But the bigger problem, what they face is, if you're launching a satellite and you want to go to a particular orbit, you may meet some of this debris on the way. Okay? And that's a much bigger problem. Let's say you are having a human mission, International Space Station is, you can see a lot of movies, Gravity and other things, right, based on that. So the effect of debris on the other existing machines in the space and humans, I think that's a very cutting edge and important problem which the scientific community is trying to address. One way to address this, they are tracking all the debris, numbering them, but there is no system about which country, how they take responsibility of their own debris. There is no clear system on that right now. That's a very, very good question.
Thank you, sir.
I don't know how much time we have, Suraj. We continue for 5 more minutes?
Yeah, you can, sir, you can.
Okay. So what do we do? I think even if you join all this organization, as I just mentioned you, what would you do as a job? I think that's just a quick list we talked about.
Hello.
You can be aerospace engineer, you can do a CAD, you can do design, you can do maintenance, you can become manufacturing engineer, you can become materials engineer, mechanical engineer, even if you, from mechanical engineer to technical sales engineer, also you can become if you want. So at the same time, you're not limited to these jobs. I think this degree can also get you to become automotive engineer, control and instrumentation engineer, energy engineer, as I am. You can actually become a patent attorney. You learn the inventions. So there are many things. But as the time goes, you need to keep calibrating yourself about again, what is your interest, what is your knowledge, what is your skill, where is the market. Keep calibrating this for. And I'm sure you can decide for yourself as you move on. So,
Sir, what is a CAD technician?
So CAD means computer aided design. So now a lot of these designs will happen on computer, right? So it's like softwares called like CATIA or Unigraphics or AutoCAD to start from. AutoCAD is the most simplest form of it. So essentially, these technicians will be expert in designing the geometry, designing the 3D in the computer. So that's called CAD technician.
Schiphol, Amsterdam International Airport, one of the world's largest airports. Here, over 50 million passengers are handled on a yearly basis, almost 3 times the entire Dutch population. These numbers show that air transport has become fully integrated in the modern society. Things have not always been like this.
At the end of the Middle Ages, we already knew a lot. Christian Huygens was already laying the foundation for the general theory of relativity. And Leonardo da Vinci even tried to design and understand airplanes. Still, actually flying remained beyond the capabilities of mankind for another 300 years, until the Wright brothers were able to take off in the first powered aircraft to carry 1 person. And then the enormous progress in the 20th century. Imagine the astonishment of the Wright brothers if they would be able to see what we can do today.
Now, there are loads of questions to be answered.
Why did it take so long for mankind to fly? What were the difficulties? What are the basic principles? And what were the technological breakthroughs which caused this rapid increase of our capabilities in the 20th century?
These and many other issues which must intrigue you will be addressed in Introduction to Aeronautical Engineering, given by Delft University of Technology.
So enroll this course, because if you board this course, your knowledge on aeronautics will truly take off.